that's so large that you really can't factor and you can't really group. And so it doesn't mean that your graph isn't going to cross the x-axis in any spots, but you need to have something else, another method with which to figure out where it's going to cross. So what we came up with was a way to identify the possible zeros. P is going to be always your last term. No, the linear term has an x, so it's the integer term, the one without the x. So it's the last value without the x. Without the x. And your q is the coefficient of the lead term. And the lead term always has the highest exponent. First term if you've got them, and if your exponents are in descending form. And we don't worry about whether or not they're positive or negative. We're going to assume that we're looking at both positive and negative values. So the first thing you do is you identify your P and your Q. And in this example, what's my P? So we don't worry about the sign. So we're just going to say it is 5. And we look at our Q, which is, okay. And we come up with our factors. All of the factors of 5 are just going to be 1 and 5. And all of the factors of 4, 2 and 4. Okay? And so our possible rational zeros, so rational means no i's. Okay? Rational means no i's. Okay? Would be a combination of the fraction, your P over your Q, plus and minus. So that's going to give me, and we want to do this in an orderly fashion, the 1 over 1, the 1 over the 2, because we're doing P over Q, and the 1 over the 4. So we've done the 1 over all of our possible denominators. Haley? It's just for the whole answer. And I'm just putting it out in front, and we're going to assume that we're looking at positive and negative answers for all of these, okay? And then we're going to skip now to the 5 as the numerator. And we're going to put it over, and then we'll put it over, and then we'll put it over. So these are my possible answers. Now we're going to, my possible zeros. Huh? It's always P over Q. So we're going to write this in an orderly fashion so that it's easy to read. And so we'll do plus and minus. The smallest value is what? 1/4. Isn't 1/4 your smallest? What's your next smallest? 1/2. And then? I'd do 5/4. And then 5/2. And then 5. So count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've accounted for them all. Sometimes we get repetitions. Like I'll go 1 over 1 and I'll have a combination of 3 over 3 also, which is just a replication of itself, and you only include it once in your final answer. So that means when I'm looking for my zeros that I'm going to use synthetic division so that I'm not just picking any number in random, I now have some numbers with which to limit my search. Does that make sense? All right, so let's do this next one. That's all. Right now, we'll do harder. I just want you to identify what are the possible P's and Q's. And what you guys will get confused on is in the next step. This says possible. I don't want the ones that work. I just want my possibilities. Okay? It's this, yeah. And because these are written in, from smallest to largest. Meg?
Why do we have 5 in the numerator and 1 in the numerator, but not 5 and 4 in the numerator? Like, how are we getting the
P over Q. 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 Yeah, we have big ones. Okay. All right, let's try the next one. What is my P? What is my Q? Factors of P are 5 and 1, and of Q are 1 and 3. So if I'm looking for my possibilities, my P over my Q, I'm going to do plus and minus. We'll start with 1. 1 over and 1 over 3, P over Q, right? And then we go to 5 over and 5 over. Okay, so now we're going to order them. Plus and minus, the smallest one is 1/3. Yeah, and then 1, and then 5/3, and then 5. Are we good? Pardon me? You just put it once. You don't repeat it. Right. Okay, you do the next one. So identify your P, identify your Q, write your factors for both, and then set up your fractions. Could be, yeah, sometimes. So in this case, it's just the factors of 20, right? Because your Q is 1. All right. Didn't see that? Okay. All right. So now notice the difference in the terminology. Find all the real ones. This doesn't mean the possibilities. I want the zeros. Oops. I want the zeros, not the possible ones. You got to do the possible ones and then eliminate down. So first you're going to find the possibles. And then you're going to use synthetic division to find the ones that work. Exactly. If it works, you get 0 as a... Well, let's think about this, Pooja. We talked about this. What's the degree of this polynomial? Cubic. How many possible answers are there? 3. Highest exponent tells you how many possible solutions there are. So if I have a cubic and I find one, then I'm left with a, what kind of a function? If I start with a cubic and I find one that works, when I write my polynomial out, I will have a quadratic. And guess what you can use on the quadratic? Yes. So what I'm not doing now that I did yesterday is I'm not giving you one to start with. You have to find the one to start with. Do you understand the difference? So we find our possible roots by doing our P over our Q. Okay? So I'm going to run out of space. I'm just going to come down here. My P is 18. My Q is 1. So my P over my Q, would you agree, are just the factors of 18? Plus and minus 1, 2, 3, 6, 9, and 18. Yes? So using synthetic division, my polynomial has coefficients of 1, -4, -15, and 18. Now this is where it gets a little tedious, because I haven't told you which one to use, but these are the ones that are my options. No, we just start till we find one, and then when we find one, we're left with a quadratic, and we use the quadratic formula, or we factor. Yeah, I do it in an orderly fashion, and I look. I don't want to keep getting bigger, and I don't want to get real small. So do I use positive or negative? Well, in this case, it's hard to tell. But let's start with -1. Let's just do, let's either start with +1 or -1. Okay? So if we start with -1, we pull down the 1, we get -1. We get -4, now we get 4. Oh, here's -5. But is it going to give me 0? Okay. Well, because this is -5, this is +5. Now this is 20. No, this is 10. I can't even do the math. This is -10. I mean, I can tell that I'm not going to get 0. So we do it again, and we'll try +1. Sure. No, that's fine. 1, -4, -15, 18. Pull down a 1. 1. -3, -18, -18, 0. So here's 1, 0. Don't forget this one. Okay? Don't forget it. Okay? That means I have x squared minus 3x minus 18 equals 0. I can use the quadratic formula, or I can factor, right? This is going to factor to x minus 6 and x plus 3, which gives me values of 6 and -3. Now, remember, how many solutions would you get at most? Because that's the degree of the polynomial. And are all of these part of my options of my P over my Q? Yeah. So we're done. Those are our 3 answers. Yes. When you would just bring it down to a quadratic. So you would take your 5th polynomial, you'd get a 4th degree polynomial. You'd look at your options, you'd do synthetic division again, and you'd get a cubic. You'd look at your options, you try another one, and you'd get it to a quadratic. I'm not going to make them that big, Rachel. Okay? Yes. The degree, the highest degree. We've talked about that. Okay? But that's what you're looking at. You're not going to have more than 3 because the degree is a 3rd degree polynomial. Well, here's the thing. The first one is not going to be like number 5, and so that you're going through a whole bunch of these. The first ones that I give you, I'll keep them simple. They're going to be between positive and -2. So you're trying maybe 2 and -2, 1 and -1. Okay? 4th degree, you'd get it down to a cubic. You take that one answer, look at all your possibilities. 4 answers, right. Now, that doesn't mean that they won't repeat. You might get 2, 2, -3, and 5. That's still 4 answers. It's just that 2 of them repeat. Okay? Yes?
What we figure out, when we figure out what the x equals with the 1 positive 1 or -1?
Well, it's just 1. As a factor, it'd be x minus 1. So my zeros then are -3, 1, and 6. We got the 1 from the synthetic, and we're left with -3 and 6. Okay, you try the next one. So do your P's over your Q's, right? And if a term is missing, what do you insert? Yes. Got them all? Did you get them all? Yeah. Try this one. See if you can figure it out. Well, you've got 8 because it's plus and minus. Don't forget. Don't forget your plus and minus. Find them? Woohoo. Okay, I got it on the first time. I got -1 works. But you might have picked a different random number. So that means -1, 2, and 7 are my zeros. And we know how to sketch the graph of this, don't we? Well, we know the zeros. Don't we know the zeros? It crosses the x-axis at -1, 2, and 7. And we know our y-intercept is 14. It's negative. This is your 0. In factored form, it would have been written as x plus 1. So we're always using that opposite sign. Okay. Are we good? Mm-hmm. Oh, that's just, yeah. It's a coincidence. Okay, the last one. It's a word problem. Find the possible values of x for a pyramid if the height is x plus 1 and the square base is the dimensions of x and the volume is 4. So volume is equal to, anybody know what the volume formula is? A pyramid? 1/3 area of the base times the height. Well, the area of a base is a square, so 1/3, and the dimensions of the square were x times x, right? Because it's a square base with dimensions x, correct? Yeah, I'm just doing a longhand for the notes. And then what's the height? X plus 1. And what is the volume equal to? 4. So that's 1/3 x squared times x plus 1, which is 1/3 x cubed plus x squared. And all of this is still equal to 4, right? Huh? What am I distributing? Oh, I can't. I can't distribute a square like an exponent. But this is just a term sitting out front, right? All right, so this is 1/3 x cubed plus 1/3 x squared. Would you agree? Do you like the denominator there? I could multiply everything by 3 to get rid of that common denominator. It was given. So 12 is equal to x cubed plus x squared. Because, right, the 3's drop out, don't they? Yeah. What's 1/3 times 3? Libby, what's the matter? Oh, okay. So then this is x cubed plus x squared minus 12 equals 0. Was this a quadratic? Is it? No. What's the highest exponent? So it's cubic, so we can't use the quadratic formula yet. Is it a 2-term? SOAP is only used on 2 terms. You do synthetic division. We're going to do P over Q, which is going to be factors of 12 over 1. So 1, 2, 3, 4, 6, and 12. Is that making sense? And what do we do when we set up our synthetic division? Careful. 1, 1, 0, and okay. I don't think so. Unless this was it +1 or -1? It was, I hope +1, good. Okay. Okay, so now we're going to use our possibilities, right? Now, do you agree that probably 1 and -1 won't work because they're not going to get you big fast enough? So let's try 2. 1, 2, 3, 6, 6. Here we go. 12, 0. Remember, I'm going to try and keep these reasonable. Okay, is this a quadratic now? Because it was a cubic, right? And if we've used synthetic division once, we brought it down to a quadratic. X squared plus 3x plus 6 equals. Now, this is a value for x. There might be others. Because we're trying to find values of x. So negative b plus and minus the square root of b squared minus 4ac all over. You could try, but it's not going to work. Okay. So negative 3 plus and minus the square root of 9 minus 24 over 2. Is this going to give me a real number? What's it going to give me? An I, an imaginary. So I right away know this gives me nothing usable.
So 2 is not a number.
No, 2 is a number. 2 is a 0. It gave me 0. But anything after that, I don't get any information. So what does x equal? 2.
It's not going to be like 12 or 3 or 2.
Nope. Because these are my other 2 solutions. How many solutions did I have? Could I have? 3, right? 2 of them are imaginary. 1 of them's real. Because I know that 9 minus 24 is negative 15 under my square root, and that's imaginary. So it's not real. It's irrational. Does that make sense? Kind of coming together for you? Okay, we're going to graph this out of curiosity. Where is the only place that this is going to cross? At 2. So it's a cubic that does something like that. Crosses it only at 2. Even though there's imaginary solutions, we can't graph those. They are not graphable on the coordinate axis.